In our previous video, we learned how to factorize by pulling out a common factor. And this video is just a little bit of an extension on that. I personally think that it's a bit of a simpler section, but it's up to you to decide for yourself. So what we're going to do here is, instead of having to find the highest common factor the way we did before, we're actually going to see that it might be a little bit clearer what the highest common factor is. So let's jump straight into the examples. Factorize the following examples. 3x times a plus 1 minus 2 times a plus 1. I hope you notice that these two brackets here are identical to each other. So what makes these types of questions unique is that instead of having to find the highest common factor, we can see that it is whatever is in those brackets. Since they are identical, we can take them out as the highest common factor. So let's do that. Let's see here. We take out a plus 1. And then again, just like before, once we've taken out our common factor, we're going to open up a bracket. Now, if I divide this first term here by a plus 1, I'm going to see that it's going to cancel out, and I'm going to be just left with 3x. And if I divide this term here by a plus 1, I'm going to see that they'll also cancel out, and I'll just be left with minus 2. So what we do essentially is we take out the common brackets, and then we put in another bracket whatever is left over. Because now if I say a plus 1 times 3x, I'll get 3x times a plus 1. And if I say a plus 1 times negative 2, I'll get negative 2 times a plus 1. So that is factorized. Let's try another example so that we can make this really clear for you. Example 2 says 2x times x plus 3 minus 5 times x plus 3. Once again, we can see that x plus 3 is the same for both of them. So I'm going to take that out as my common factor. Keep it in its brackets, don't forget. Once you've taken out your common factor, you open up brackets. And now we can say, if I get rid of this x plus 3, what's left over in this first term? 2x. Technically, what I'm doing is I'm dividing this whole term by x plus 3. My x plus 3s are canceling out, and I'm being left with a 2x. Now, if I take out an x plus 3, what am I left with from this term? You might be tempted to say plus 5, but be very careful. This sign over here is applicable to the 5, so you're left with minus 5. And that's it. That's everything factorized. Easy peasy, lemon squeezy. So here I've got a times 2a minus 1 plus 8 times 2a minus 1. And once again, I can see that these brackets are identical. So I'm going to take them out as my common factor. I've got 2a minus 1, and I'm going to say, well, if I get rid of this 2a minus 1, I'm left with an a from the first term, and I'm left with a plus 8 from the second term. And that's that. I'm hoping that you're starting to pick up the trend, but now we're going to do a slightly different example. So just be forewarned that something's going to be a little different towards the end. But let's approach this the way we have before. Here we have an a plus 1, and here we have an a plus 1. So I'm going to take it out as my common factor, a plus 1. And then I'm going to open up my bracket and see that I've got a 5a left, and here I've got a minus 10 left. And now you might be tempted to say, look at that, I'm done, no more. Except that the question told us to factorize fully. And if you look in the second bracket over here, you can see that there is a common factor between those two terms. So we need to take out that common factor. I hope that you can see that the highest common factor between 5a and minus 10 is going to be 5. So I'm going to put that right at the front because numbers like to hang out at the front. I'm going to pop down that a plus 1 like we had before. And I'm going to say 5a divided by 5 is just going to give me a. And negative 10 divided by 5 is going to give me negative 2. So when we do ones like this, we just need to double check that at the end, everything is fully factorized. If you had done this just like this, you would have gotten 1 mark there for pulling out your common factor correctly. But here, you would have gotten your additional mark for being able to recognize that it wasn't fully factorized until we took out that common factor. I'm just going to do it one more time in the hopes that it'll make it a bit clearer. All right. So just like before, we're going to take out the bracket that's common, so that's a plus 1. And then I'm left with another bracket with 5a a minus 10. But now if I look very carefully here, I can see that there's a highest common factor between those two numbers, which means this isn't factorized as far as it could be. So what I'm going to do is I could write this here, a plus 1, and then I'm going to take out the common factor, which I hope you can see is 5. And then what I'm left with is a minus 2. But in maths, we don't really like putting our numbers randomly like that in the middle. So I'm going to move it to the front, and I've got 5 times a plus 1, a minus 2. And the reason I can move that is because if you remember, 2 times 3 is the same as 3 times 2. So the order that we're multiplying in doesn't really matter. Okay, guys, that's a toughie. But now we're going to move on to a slightly different problem. So here we've got example 5. And you can see here we've got x minus y in the bracket, and then here we have y minus x. Here the x is positive, but here the x is negative. Here the y is negative, but here the y is positive. So I hope that you can see that we're in a bit of a pickle because now our variables have opposite signs to each other. So this is a little bit tricky, so pay attention. At the moment, I have x minus y here, and I have y minus x over here. I need to try and find a way to change one of them. So what I like to do is I prefer to change the second bracket. So what I'm going to do is I'm going to say a times x minus y, leave that first bit the same. And now if I wanted to make this a positive x instead of a negative x, I think that the best thing to do would be to multiply by a negative 1. Or if I wanted to change this positive y to a negative y, I could multiply by a negative 1. I'm going to take whatever's in the front here and multiply it by negative 1. It's going to be negative b or negative 1b. But now, because I've changed that, I've multiplied that by a negative 1, I can change the signs inside the bracket. Okay, so now I've gone from y minus x to x minus y, but only because I've also changed the sign on the outside. So you can change the sign on the inside of the brackets, but you have to change the sign for both terms if you change the sign on the outside of the brackets too. And now we've got something where they're identical. So now I can say, take out x minus y as my common bracket, and then what's left from the first term is a, what's left from the second term is b. There's no common factors between a and b, so there we go. This is fully factorized. Remember, if you want to change the signs inside the bracket, you have to change the sign just outside the bracket as well. I'm going to do one more example of these because this can be really tricky. Okay, so here I've got 7 times x minus 2 minus a times 2 minus x. So here I've got an x minus 2, but here I've got a 2 minus x. Again, this x isn't positive, but this one is negative. This 2 is negative, but this 2 is positive. So they're not exactly the same. So what I'm going to do is I'm going to change the second bracket. I'm going to leave this first one as it is. And now what I want is I want to be able to write x minus 2, meaning that I've changed this sign from negative to positive and this sign from positive to negative. But if I want to change the signs inside the brackets, I have to change the sign outside the bracket as well. So here we have negative a, so now I'm going to write positive a. Okay, now let's just quickly cover why this works. Let's go here and see why this works. Well, if I multiply this out, I'm going to get negative a times 2 is going to be negative 2a. Negative a times negative x is going to give me positive ax. Now let's just check this new bit that we wrote because we're basically saying it's the same. So let's check if it is the same. So positive a times x is ax, and positive a times negative 2 is negative 2a. So these two are exactly the same because 2 plus 3 is the same as 3 plus 2. So negative 2a, negative 2a, ax, ax. For adding, it doesn't matter what order you're adding it in. Okay, I hope that made some sense. Here we can see that we've got x minus 2, and now here we also have x minus 2. So x minus 2, and what's left from the first term? 7, and what's left from the second term? Plus a. There's no common factors in this bracket, and there's no common factors in this bracket. So we're done. These last two examples are probably the trickiest type of examples you can get. Just remember, if you want to change the signs inside the brackets, you also have to change the sign outside the bracket, because at the end of the day, we want it to mean the same thing. We want it to multiply out to be exactly the same, whether there's a minus a or a plus a. I hope that was helpful. I strongly recommend that you guys go through this video slowly and go through the examples once again. The tricky ones are number 4, 5, and 6. So really take your time with those three and make sure you understand. All right, guys, good luck.